Why one-tailed p-values are rarely appropriate. In this video, I'll explain why one's choice of a one-tailed or two-tailed p-value matters, and then I'll talk about different ways that you can make the choice of whether you should use a one-tailed or two-tailed value. The first approach is very common, called the directional hypothesis approach, and I'm going to argue that it's not a good approach and we should abandon it. Then I'll describe what might be called a what would I do approach, and I'll argue that that's better. And throughout the video, I'll try and explain why a one-tailed p-value is rarely appropriate in most research situations. In a previous video, I described how to interpret p-values. Generally speaking, a smaller p-value is stronger evidence against the null hypothesis. Common guidelines are a p-value that is close to 0.2 or higher is considered to be consistent with the null hypothesis. A p-value close to 0.1 is considered weak evidence against the null hypothesis. P-values close to 0.05 are considered moderate evidence against the null, and p-values of 0.01 are considered strong evidence against the null hypothesis. Researchers must choose whether they plan to use a one-tailed or two-tailed p-value before they conduct their research. You can see in this example that if I ran a study and got a t-value of 1.65 and I was doing a two-tailed test, the p-value would be weak evidence against the null hypothesis, a p equal to 0.1. However, the same data would yield moderate evidence against the null if I had planned to do a one-tailed test. A researcher's choice of whether they should use a one- or two-tailed p-value is actually linked to the null hypothesis that they're testing in their study. And of course, the null hypothesis is set up before they actually collect their data. It might be tempting to always use one-tailed p-values because they're always going to be smaller than two-tailed p-values, thereby providing stronger evidence against the null. But that's really not appropriate because one-tailed p-values and two-tailed p-values don't mean the same thing. And I'll explain that on the next slide. Imagine a situation in which a researcher is trying to test if a drug has an effect on memory. Further, imagine that the researcher chooses to test a two-tailed null hypothesis, specifically that this drug does not affect memory at all. The p-value that the researcher has chosen is really looking to find evidence in two different tails, or three different categories. The result can find evidence that the drug increases memory, it can find evidence that the drug decreases memory, or it can find that there's not sufficient evidence to say that it has any effect on memory. This type of setup is looking for three different categories of possible outcomes. However, in a one-tailed null hypothesis experiment, specifically testing the hypothesis that the drug does not increase memory, the p-value is set up to find really evidence in just one tail. It's trying to find if there's sufficient evidence to conclude that the drug increases memory scores. And so there's just two categories, and the other category is there's just insufficient evidence to say that the drug increases memory. These two setups are not interchangeable. You have to pick which one of these you are testing for when you design your study. Changing it after the fact is inappropriate. They're not interchangeable. A very common approach to making the choice between one- and two-tailed p-values is the directional hypothesis approach. If a researcher expects the treatment will cause an increase in a certain dependent variable, then they would say a one-tailed test is justified. For example, if a researcher expects a drug will increase memory scores, they might plan to use a one-tailed test. In this type of situation, the null hypothesis that they're actually planning to test is that the drug will not increase scores. If the researcher is testing that one-tailed null hypothesis that drug scores do not increase memory, and they, for some unexpected reason, find that the drug actually decreases memory, and they get a result that indicates the p-value is 0.99, they would have very compelling evidence that the data are consistent with the null. It is very compelling that the drug does not increase memory. However, if they had planned their study to be a two-tailed test, their conclusion would be very different. If they had been testing the two-tailed null hypothesis, that the drug does not affect memory scores, it doesn't change it, increasing it or decreasing it, the same outcome would have a p-value of 0.01, which would be strong evidence against the null. Of course, it's a different null hypothesis. Here they would have evidence to say that they have strong evidence that the drug actually decreases memory. If the original null hypothesis was one-tailed, that the drug does not increase memory, it is not appropriate for a researcher to then use a p-value of 0.99 to argue that the drug actually decreases memory. You're limited to the null hypothesis that you started with. If you're going to use a one-tailed test honestly, you can't use a null result, like a p equals 0.99, to report an important finding